Alright, let's go ahead and find the horizontal asymptote of each of these functions. First thing I'm going to do is I'm going to locate the highest degree for each of the numerator and denominator. Now I'm going to circle them. So I have 5x to the third over x squared. Here is the numerator or top degree, and this is the bottom degree. What do you notice about from 3 to 2? What inequality is it? Less than, equals, or greater than? It's greater than. So because this degree, 3, is greater than 2, there is no horizontal asymptote. There is no horizontal asymptote. Let's make a quick sketch, and this will make sense graphically. So to review, when you have a fraction, this is called a rational function. So let's go ahead and graph this rational function. And remember, because it is a fraction, you should be starting with the parentheses. So parentheses 5xxx divided by xx minus 4x plus 2. And I'm going to press zoom 6. Ooh, crazy looking graph, right? Let's double check my stat plots are off. They are. Our window, we changed it. Excellent. So over here, what does that look like, class? It looks like a vertical asymptote. So let's do a quick review just because I want to get a graph. Friday's lesson was if you just took that and you set it equal to 0, or really essentially not equal to 0, x squared minus 4x plus 2, and class, is that factorable? Two numbers that multiply to be 2 but add to be negative 4? No number, right? So I'll just use my calculator to get some answers for me. I'll do solver. So math, then you go up, press solver, and then I'm going to go back up to write in my function. X squared minus 4x plus 2. And then I'm going to guess, 10 is fine, alpha, enter. And I have an answer at 3.4. So essentially, if you're solving quadratics, right, that means my answer cannot be 3.41. There's an asymptote there. And let's just say I guess at negative 10, alpha, enter, for solving it. Then I have another one at 0.58. So again, this was a quick review of Friday's lesson. So if I draw my asymptote at around approximately 3.5, dotted line. And I have another one at 5.8, so between 0 and 1. Think of money when we start thinking about decimals. And it looks a little bit crazy if, if you have the newer calculator, this one's not going to actually have the asymptotes. Let's take a look at your graph. Looks a little bit cleaner, right? I like this one better. So something like that. And I want you to point out something also on your graphs. Do you notice how the asymptote separates this one into 3 areas? Count with me. Ready, set, go. So I should actually have 3 graphs, but I only have 2 in my calculator. What does that mean? We have to change the window. So Let's go to y minimum. I don't care about that. Y max, let's change it to 100 and count by tens. See what happens. Do you see that? It showed up. And here's another way that we know already this graphically. We already said that there is no horizontal asymptote. That's the big idea for this problem. And I just want to show you that when I sketch that graph, it actually looks like there's some kind of horizontal, slanted asymptote. Do you see that? So big idea, zoom out just so you can see it, but I wanted to show you graphically that there are no horizontal asymptotes.